So for the introduction, linear algebra extends its reach into all parts of science and mathematics. In chemistry, one of linear algebra technique can be used to solve one of chemistry inescapable task of balancing chemical equation. Balancing chemical equation is fundamental when it comes to laboratory works, as a ratio of reagent and products is vital to the most chemical reaction. This is taught and drilled into the head of chemistry student. The further a student studies chemistry, the simpler the task becomes, but it can still be tiring and takes up valuable laboratory time. However, be observed that when balancing a chemical equation, system can be formed from the process. This study does illustrate a way to construct a homogeneous system of equations whose solution provides appropriate value to balance the atom within the reactant and within the product using algebra. Problem statement: chemical equations are important in both theoretical and practical chemistry. As a result, the balanced equation is extremely useful in a variety of chemistry domains. Many students struggle in balancing chemical reaction equation in their first chemistry studies. The most utilized method, for example, but not limited to, is inspection. It is frequently assumed to be a trial and error method, hence it can only be applied for simple chemical reaction. So, how do we apply linear algebra to balance chemical equation? That is the thing that we will prove using an appropriate method like Gauss-Jordan elimination method. For the question, balance the chemical reaction combustion ethanol. This chemical reaction consists of three elements: carbon, hydrogen, and oxygen.
So now, let's move on to the objective of this case study. The first one is to convert linear equation into an augmented matrix form so that we can solve the problem with much easier. The next one is to produce balanced chemical equation besides using the normal balancing method. The last one is to adapt the Gauss-Jordan elimination method in balancing the chemical equation. Next, methodology. In methodology, we will be focusing on how to produce balanced chemical equation using Gauss-Jordan elimination method. For the example, we will use the combustion of ethanol. This is the chemical equation for combustion of ethanol. For the first step, we will assign 4 unknown coefficients into the equation. Next, we will form the simultaneous equation by sorting them into their group. After that, we will convert the simultaneous equation in homogeneous equation, and at the end, we will get the augmented matrix form. Moving on to the calculation. In the calculation, we will use the Gauss-Jordan elimination method, where we reduce the augmented matrix into reduced row echelon matrix or R2EM form. First step, we must have the leading one for the first row. Therefore, we will interchange the third row and the first row. Next, we need to make sure all the entries below leading first are zeros. So, we will multiply the first row with -6 and adding it to second row. Also, we will multiply the first row with -2 and adding it to third row. For the second step, we will make the leading one for second row by multiplying it with -1/12. Next, we will make sure the entries below and above leading one are zeros. So, we will multiply the second row with -2 and adding it to first row. After that, we will do the same by multiplying the second row with 4 and adding it to the third row. Lastly, for the third row, we will have the leading one by multiplying it with -1. Then we will add the third row into second row so that all the entries above leading one will be zeros.
After we calculate in methodology, we obtain a result from the linear equation, which is x1 minus 1 over 3x4 equal to 0, x2 minus x4 equal to 0, and x3 minus 2 over 3x4 equal to 0. Then we let x4 as t, and we will get the answer for x1 equal to 1 over 3t, x2 equal to t, and x3 equal to 2 over 3t. We noted that t is a parameter, then we assign the value to parameters such as t equal to 1, and then we obtain a specific solution, which is x1 equal to 1 over 3, x2 equal to 1, x3 equal to 2 over 3, and x4 equal to 1. As a result, we obtain a balanced chemical equation is 1 over 3 C2H5OH plus 1 O2, 2 over 3 CO2 plus 1 H2O. However, the chemical equation that we obtain is not balanced yet. In chemistry, all coefficients must be integers and the smallest values will be used to balance it. Hence, we multiplying both sides by 3. It is because the positive integer value and the smallest value that we can make the equation to the balance is by multiply it by 3. Then we get 1C2H5OH plus 3O2, 2CO2 plus 3H2O. All in all, from the problem statement, we need to balance the chemical reaction combustion of ethanol, which consists of 3 elements as carbon C, oxygen O, and hydrogen H. From the result that we obtained just now, we can see that to produce balanced combustion of ethanol equation, we need 1 mole of ethanol and 3 moles of oxygen, which will produce 2 moles of carbon dioxide and 3 moles of water. Overall, we can conclude that the Gauss-Jordan elimination method is very suitable method for balancing chemical equation. Besides that, linear algebra not only can be applied in chemistry, also it can be applied in many fields such as cryptography, inventing new games, image processing, and others. Our world cannot be standing perfectly if it by itself, so it needs others to complete its life. Same goes to connection between linear algebra and other fields.